If you want to be comfortable with IT security, you need to be comfortable with the basic local area network. And if you want to be basically comfortable with the basic local area network, well, then you have to be comfortable with the OSI 7-layer model. The OSI 7-layer model has been around for 30 plus years. I'm not even sure. It's been around for a long time. And like any model, it is a representation of how something should work. So this is a network model, so it's a representation of how a network should work. Now, if you were to look on any given local area network, a wired one, let's just stick with that to keep it simple for a minute, what you're going to see zipping between individual hosts are Ethernet frames. So this is my stylized Ethernet frame, plus it gives me a chance to play with blocks. That's always fun. And what we're going to be doing is we're going to be talking about the OSI 7-layer model, but we're going to be talking about it in terms of how your individual systems deal with these frames that are moving back and forth between each other. So we're going to be seeing a lot of this. Now, the OSI 7-layer model is aptly named because, well, it's got 7 layers. So when you're looking at these layers, I want you to think of them as though they're like an apartment blocks, one stacked right upon the other, and there's like this lazy Susan that moves data between them. Understanding the function of the OSI 7-layer model makes it easy to understand how networks and how to secure them all comes together. So let's go ahead and get started. We're going to have an incoming Ethernet frame, and we're going to start way down there at layer 1. Hi, I'm layer 1, or the physical layer of the OSI 7-layer model. I'm way down at the bottom because my job is to make sure that ones and zeros get between different hosts. So I deal with specifications like how thick of copper wire do we use for the cabling, or if it's wireless, I'm the one who deals with what's the frequency of the radio waves we're going to be using. So layer 1 deals with getting the ones and zeros from one system to another. Now, I'm actually also going to pretend like I'm the network card in your system. So what's going to happen here is I've got this incoming, this is a piece of RJ45 coming in from my network. My job is to act as a catcher, in essence, for Ethernet frames as they come in. Now, when I take a look at the Ethernet frame like this, the only thing I'm going to be dealing with is, first of all, the preamble right here. Now, the preamble is basically the warning sign. It's a bunch of ones and zeros that alternate, and it warns the network card that there's an incoming frame. So once it's actually in, I'm going to go ahead and strip off the preamble. I don't need him anymore. And here at the end is the frame check sequence, which is basically a way to make sure that the data that was sent is the same as the data that was received in case there's interference or something. So once that's done, we don't need this anymore. So we are now staring at an Ethernet frame. It's still an Ethernet frame, but we've just had some of the more basic stuff stripped away. So what I'm going to do now is I'm going to connect this to my little handy lazy Susan, and I'm going to say, crank it up to the next layer. Go ahead, boys. And now it's going to head up to the next layer of the OSI 7-layer model, the data link layer. Hi, I'm layer 2 of the OSI 7-layer model, the data link layer. My job is to allow individual systems to be addressed in such a way that Ethernet frames get to the right spot. So I'm going to be inspecting incoming frames to see if they're addressed for me based on my MAC address. So remember, MAC addresses are a unique 48-bit value that's burned into every network card, wired or wireless, on Earth. So I'm going to be taking stuff coming up from layer 1, and I take a look at this, and what I'm going to be doing is checking out right here. This is the destination MAC address. I, as a network card, have this MAC address burned in to me, and all I need to do is compare this address to my burned in address, and if it's a match, this is a frame that's for me. If it's not for me, I'm just going to erase it and make it go away. So now that we know that this particular frame is for me, I'm going to pull off this MAC information. Now, I'm not going to just throw this away, because the other thing I have right here is called a source MAC. I'm going to later use this to be able to send it back to whoever sent me this frame. So we're going to set this off to the side. So now I've got an IP packet. I've done my job. I know that this frame is in the right spot. I've stripped away the MAC information, and now my job is to send this up to the next layer of the OSI 7-layer model, the network layer. Hi, I'm layer 3 of the OSI 7-layer model, the networking layer. MAC addresses are physical addresses burned into every network card, and they're great for moving data between individual systems on a local area network. But when you start having large distributed networks like, I don't know, the internet itself, MAC addressing is insufficient. And that's why we use logical addressing like the famous IP addresses. And that's my job at layer 3. I take a look at the incoming packets, look at the IP addresses, and make sure that it's going to the right place, in particular, me. So as I see a packet coming up from lower layers, I'm going to take a look at this. And the first thing I'm going to notice is the destination IP address. If that's my address, I know it's for me. And I also notice that there is a source IP address. So what I'm going to do at this point is I'm going to strip these away. Now again, just like we did with MAC addresses at layer 2, we're going to go ahead and keep the source IP address in case we want to talk back to the person. And what I'm going to do now is I'm going to take all this information and send it up to layer 4, the transport layer. Hi, I'm layer 4 of the OSI 7-layer model, the transport layer. My job is to assemble and disassemble different pieces of data as they come in. So when I take a look at an incoming piece of data, now I look at this, you'll notice right here, you see what that says data? That's a little bit of a misnomer because in reality, data can be really, really big. So I'm going to move this off to the side for a minute and do something more like this. Each individual Ethernet frame can only hold 1,500 bytes of data maximum. So at the transport layer, my job, if I'm sending stuff out, is to take what a Word document or a video or whatever it is, and I chop it up into 1,500 byte chunks so that it has individual frames can send it out. Equally, if they're incoming, I'm the reassembly guy. So if you take a look at these data pieces I have here, so we'll say that this is a Word document that takes up exactly 4,500 bytes. So in this case, my job is to break it up into 3 pieces. Think about like if you ever received a bunch of boxes and it says box 1 of 30, box 2 of 30, box 3 of 30, they sequence them. We do the same thing at layer 4 of the OSI 7-layer model. So that's my job, and really I'm just an assembler and disassembler. So once that's verified, there's not much for me to do except send it up the stream. Hi, I'm layer 5 of the OSI 7-layer model, the session layer. The session layer is the part of your host that actually makes the connection to the remote host. So this is where I'm establishing a connection, say, to a web server if I'm a web browser, or if it's an email client, I'm connecting to an email server, whatever it might be. So once I establish that connection, then data can go ahead and move back and forth between the 2 individual systems. So for me, the thing to remember about the session layer more than anything else is that if the IP address gets the data to the right computer, it is the port numbers, which are part of your packet, that get the data to the right application. So if you've ever had a web browser, you got 5 tabs running, you wondered how it remembers how to get the right data to the right tab, it's because we always use our port numbers. So what I'm going to be doing is I'm going to be taking data from lower levels, and then I'm going to go ahead and, I'm going to keep these port information because again, I might want to send somebody back. You'll notice there's a destination port, and every individual session I have has its own unique port number at any given moment. And then we have a source port, which is whoever's on the other end where their connection is. So I'm going to set these off to the side, and now I have a little piece of data, and this data, which is all reconnected and everything, goes straight to the application. But there's a problem, and the problem is that when I send this up, is the application going to actually be able to read that data? Hi, I'm layer 6 of the OSI 7-layer model, the presentation layer. My job is to make sure that data not only gets to the right application, but more importantly, gets it in a format that the application can view. Now, in today's modern world, this would be confusing. You'd go, no, wait a minute, Mike. So if I've got a web page coming in from a web server, are you saying my web browser may not know how to read it? Well, there was a time where that could be true. The thing is, today, all of our applications are so good, they can read just about anything. So my job, let me get a piece of data that's coming up, isn't that important anymore. So it used to be that I would have to convert this data. Let's say if it was a Microsoft Word was going on the network to get a Word document, but I had a WordPerfect document or some other competitor, I would have to go through the conversions so that it could read it. But today everybody reads everybody. If you were to ask me, if there was one of the 7 layers we could get rid of, it's the presentation layer. He's just not that important anymore. So what I'm going to do is I'm going to put my data on here and send it up to the top, and this is going to be called the application layer. Hi, I'm the 7th layer of the OSI 7-layer model, the application layer. Now, when you hear the word application layer, you think, well, this is the applications. It's not really the applications. It's the smarts built into applications so that when data comes up from lower layers, that I as an application can actually read this thing. So the application layer shows up in kind of interesting ways. For example, have you ever used Microsoft Word and you do a file open? You can go into your network, can't you? Go into the network and pick something on a network folder far away. That's because built into Word is an Application Programmer's Interface, or API, which gives it the smarts to talk networky. So that's very, very important. We have to have applications that can actually read and deal with the data, because that's the whole reason we're doing networking in the first place. Now, for the exam, make sure you're comfortable with the 7 OSI layers. You're not really going to be quizzed on the OSI. I'm going to tell you right now. You're going to receive questions that just say things like, Mike's working at layer 3 of the OSI and blah, blah, blah. So it's not so much you're going to be quizzed on what the 7 layers are, but a real understanding of what each one does. This is a powerful tool to help you in terms of diagnostics and making sure that you've got good security for your IT infrastructure.